Trigonometry, Chapter 1, Trigonometric Functions, Section 1, Angles, Video 7, Coterminal Angles. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. First off, I owe you an apology. The past video or two or so had lesser audio quality because I had the microphone on my headset up. Hopefully the audio quality is better now. All right, let's get this show started. Maybe. There we go. All right, as mentioned in previous videos, it's possible for an angle in standard position to have a measure greater than 360 degrees. We can also have angles with negative measure if they rotate clockwise. As such, it's possible for different angle measures to have the same terminal sides. In other words, if we can go beyond one rotation, then we have multiple opportunities to stop at the same terminal side. Two angles that have the same terminal side when in standard position are called coterminal angles. Coterminal, both terminal. For example, find two angles, one positive and one negative, that are coterminal with 40 degrees. Here we have a picture of 40 degrees in standard position, initial side on the positive x-axis, vertex at the origin, and because it's positive, it's rotating counterclockwise. To find a positive coterminal angle, we should rotate beyond 40 degrees in a counterclockwise direction until we end with the same terminal side as 40 degrees. So first, we complete a revolution. There's 360 degrees, starting it in standard position. And then we need to rotate 40 degrees more. So the net rotation is 360 degrees plus 40 degrees, which is 400. Well, that was pretty easy. Just make one more rotation. In other words, add 360. And we get 400 degrees total. Notice this is the positive angle because it's rotating counterclockwise from standard position. Now, within the solution is the key to locating terminal angles. To end at the same terminal side, we simply need to rotate a complete revolution, which translates to adding 360 degrees to the given angle. Now, if we want to find a negative coterminal angle, we simply have to rotate one or more complete revolutions in the clockwise direction. This translates to subtracting 360 degrees from the given angle. So to find a negative coterminal angle, we simply subtract 360. So we have our 40-degree angle in red, and notice we have a negative 360-degree angle rotating clockwise, and 40 degrees minus 360 degrees is negative 320. And the angle would look like that. Notice it is going in the negative direction because it's rotating clockwise from standard position. Now, before we proceed, I need to introduce a convention common to trigonometry because this was driving me crazy when I was setting up this video. Technically, an angle and its measure are two different things. An angle is an object and its measure is a number associated with this object. However, for convenience, we will use these terms interchangeably when the context clarifies if we're talking about an angle or its measure. Thus, as we move forward, I'll be using the word angle to mean both an object and its measure. Which I'm referring to should be clear based on the context in which I use the word. Now, to find angles coterminal to a given angle theta, we're talking generically now, we simply add or subtract 360 as necessary. Thus, to represent all angles coterminal to theta, we write theta plus 360 in degrees, where n is any integer, in other words, any whole number, positive or negative, or zero. For example, calculate two positive and two negative coterminal angles to 500 degrees. Well, let's take the expression theta plus 360n and let theta equal 500, and let n equal some different integer values. I've set up a table where n goes from -2 to 2, and the values of the expression 500 plus 360 in degrees are given. Notice we don't have enough negative angles. We generated 3 positive coterminal angles, but only 1 negative coterminal angle. To generate another negative coterminal angle, we can let n equal -3, and we would get -580 degrees. Now, this is important. Two angles are coterminal if and only if their difference is a multiple of 360. If you think about it, it makes sense because if we have two angles that stop at the same place, the only difference between them is how many circles we rotate in one particular direction. So to determine if a pair of angles are coterminal, all we have to do is calculate each difference and see if it's a multiple of 360. The difference is easy. Just subtract. Here's the differences of all the pairs of angles. Which are multiples of 360? Well, to see if a number is a multiple of 360, divide by 360 and see if the quotient is a whole number. Here's all the differences divided by 360. Notice the first two are whole numbers, 5 and 3. Last one's not. So only A and B are the differences multiples of 360, and so the only coterminal angle pairs are in A and B. Now you try. Pause the video and try each problem. 1. Find a positive and negative coterminal angle to negative 450 degrees. And number 2, determine if the angles are coterminal, 270 degrees and 180 degrees. Pause the video and try them. Here's your spoiler alert. If you haven't paused the video and try them, you'll need to do it now because answers are incoming in 3, 2, 1, answers. I do want to point out for the answer to number 1, you could say negative 810 degrees. You could also say negative 90 degrees. The negative 90 was found while we were trying to find a positive coterminal angle, but it's negative and it's also coterminal.